Okay, we're going to talk about functions. Now, okay, so here we go. We've got a little bookstore here, selling books. Looks like we've got a little table here, some graph. Right, okay, so one book costs you $5.50. Two books cost you $8. Four books cost you $13, based on this equation up here. Okay, so we've got a nice straight line graph. So what we're trying to get at here is we've got some one-to-one correspondence that this one book costs $5.50, two book costs $8. Okay, so some sort of relationship going on that you can look at. It's fairly straightforward. Let's have a look at something else now. Now, okay, so now if you think about the books, previous example, that one book which costs $5.50, it doesn't cost $6 all of a sudden. We're not talking about sales or bartering. I don't have two stickers on it. It's $5.50 or it's $6. No, it's $5.50. That's what the book costs. Okay. Now another book, Moby Dick can cost $5.50. Jane Eyre can cost $5.50. That's okay. Different books can have the same price, but one book can have two different prices. I'm not talking about different stores. I'm saying right here, right now. It's $5.50. No, it's $6. No, it's $5.50. It's $6. I mean, we're not bartering here. It's got a price. All right. So let's have a look at this. Each person corresponds DNA. One person cannot have two different DNAs. Right. Now, it might be possible if you were cloned for two people to have the same DNA. I don't have twins have the same DNA. Like two books can have the same price. That's okay. Two people have the same DNA. It's possible. Clone, twins, I don't know. But one person cannot have two different DNAs. I've got my DNA. That's it. All right. Blue spruce. I'm recording this around about close to Christmas time. So trees. I've got to get a Christmas tree. It's $50. Okay, 6 foot at $50. It's not $60 as well, right? It's one price. Now, two different trees can be $50. Again, this one tree could have two different prices. Okay, I'm at one place. It's $50. All right. But that tree over there and that tree over here, that can be $50. Okay. So again, just think about this. Each real number, the square of that number, 4 squared is 16. It's not 17 as well. All right. Can you see? 4 cannot be 16 and 17. Okay. 4 is 16, 4 squared. But negative 4 can be 16. Okay. So negative 4 and positive 4 both can be 16. That's okay. All right. So again, each correspondence, first set is the domain. And if you see on the, we get to graphs, is the x-axis we call the domain. Okay. What's the domain on the x-axis? And the second set, the range, and that will be the y-axis when you start to graph things. That's for later. Okay. There. Definition of function down there. Right. Have a look at this. Now, here we go. So remember, here's a classic, definitely functions. Negative 6 squared can be 36. Positive 6 squared can be 36. 0 squared is 0. This is all okay. Okay. Again, but 6 squared cannot be 36 and 37. I'm thinking about branching off. When you think, look below, little hint below. You can't branch off, from that left one, from the input, from like the x. You can't branch off to two different things. You can't have two different answers for the same thing. Right. So George W. Bush down there, can he nominate at the same time appoint Supreme Court justice at two different Supreme Court? No, there's only one. You can just do one. You can't say you and you. No, I know I'm the justice. No. This is politics anyway. Okay, but that's why B is not a function. Just visually, again, when we look at George W. Bush, Jefferson, and Obama going to two different. No, okay, B is not a function. Okay, visually. Right, now, okay, so now we've got some x and y coordinates. Now, can you see here, straight away, that I've circled, that doesn't like a function to me. 9 can't have two different outputs. You can have two different answers from 9, whatever this is, whatever's going on here. Okay, figure 2 looks good, figure 3 looks good, but let's have a look over here. Here it is. Let's get the pen going. So, again, 9 cannot have negative 5 and positive 5 as answers. All right, you can't have that. Let's have a look down for B. Right, negative 2 producing 5. Well, again, we can see visually. It's okay. Again, I don't have this one thing producing two different answers. This x producing two different y's like A has. That's bad. Now, if we look at the domain and range, so remember, domains x values, the range, the y values. So let's have a look. So all I do is write negative 2, 5. Let's get an arrow going for this. So negative 2, 5, 0, and 4. That's the x's. Okay, where is it? Down here. B. That's the domain. Okay. The y values 5, 7, 1, negative 2. The range 5, 7. That's it. Okay. Now, if you look at figure 3, we don't have to write here. Okay, so negative 5, 0, and 6 would be the domain. But 3, 3, and 3, you just have to write it once. Here it is down here. Okay, so domain and range. And if I look here, I think sometimes, I'm looking at this going, okay, domain. We've got 8, 6, negative 7, 10, and 1. Those are the x values. What order have we got it in here? I think it looks like A. They've switched the order around a bit, so I've got to kind of look at this closely. The range 7, 4, 8, 3, -2. I think it's that. I think it looks like A. Okay, so you're going to get the idea of the X's of the domains and the Y's of the range. Okay,